think I want to test this first before I implement operator ++. How can we test this? Well, load it up. Scatter. Really? That's a lot of the same. I don't think that worked. It just prints the same thing as the input. Why? Damn it. So I'm start with some random partition and I'm calling sBegin on that, and then we dereference it. And then we get back a partition that is. Oh wait, I'm all. It's finding back the same local maxima. Yeah, I should print it here. Okay, that's better. Yeah. So it removed J and O from this group and added it to its own group, and it removed the HLP from this one. Yeah, or CIM. So it split it up in two groups. And I'm not incrementing anything, so this is infinitely often the same thing. Can we understand that? I guess the reason is that this is not doing anything. So just this loop never ends. It just keeps doing the same thing. Okay. Yeah, I better implement it then. I think that the way I want to implement this is by sorting and group iterators, by score. Let's see. Yeah. So basically what we have is a bunch of iterators, the group iterators. Let's say I have 3 group iterators. Also arrows. And they are sorted high to low. So let's say I have 104, 68, and let's say 90, and then after that I get let's say 89, 70, and 65, and then we get say 50, 55, and 40. Then we begin with this, and the iterator is then supposed to keep all the values as high as possible, but I do not really want to look at the next one yet, or should I? Because it's not that that important. It's more like get a reasonable cutoff where we only use mostly high values. So I can just look at the 104 and go to the next one. So the ones and zeros. And Timothy, yay, you were the first. So in the first case we do the top line, and then I'm changing a single iterator. Let's change the one that has the highest value, so then the 104 becomes 89, and the rest stays the same. And then we change the 90, because 90 is now the largest one. That becomes 65, and now this one is the largest, so the next one is then and then we will change. Oh, that's not the right order. Okay, let's make this one also 68, because there is a possibility that the score is the same. There are actually pairs scores together with an iterator that points to what we will actually use then. So we do use this second key as well. And then we go to 50, 55, 65, and then we go to 50, 55, 40, and then we go to 50, and we are at the bottom. Yeah, so that's what I want. This is, we must iterate over these values by changing the actual iterators that we have one by one, and every time I want to change the one with that is the highest. Now after, I mean, it would be nice if I had them ordered in decreasing order. Yeah, what the hell. So now the 90 is first. However, after decreasing the 104 to 89, it's become less. So now this value has to be swapped with the 90, like that, and then we decrease. Well, wait, that's. Well, I don't know. Typing it out doesn't really make sense, I think. I just code it. The only thing is that I have to make the decision if I just scan over this vector, searching for the highest score every time, which sounds less efficient than keeping them in a certain order and then only removing and reinserting the one that just changed. And so I think I should sort my list of iterators by score. So let's do that immediately after we generated them. So we want to sort and group iterators, which is a vector. So we can run standard sort on it. And now we need some kind of compare functor. Find it here. And the functor is a boolean it must have a, I mean, it is a functor because it has an operator like this. Let's implement it right here. And the arguments are just 2 times the value type of the vector. And the value type of the vector is a standard pair. So by const reference, left hand side, and the right hand side. And I want to order these things by score, so we're not interested in group index at all. I have to get the group from the iterator. So group left hand side. So that's the left hand side dot first. We get the group iterator scatter. And if you dereference that, you get a group. Then I can get the group of the right hand side by dereferencing the right hand side iterator. And now we return the score return true if the score of the left hand side group is less than the score of the right hand side group. So now this should order that thing then in the order of score. This is increasing score. I want to have a decreasing score, right? Let me think. Yeah, I want to have the highest score first. So I just let do larger than. So now we have these things here ordered from the highest score to the lowest score. So this column is still in the wrong place. We have this, so it's ordered from high to low, so like that. And therefore we can simply increment the first iterator. This iterator has the highest score, so we just increment that one to get 89. That would be the first step. So this points to a pair and we want to increment the first iterator. That's like I think that's like this, right? Yep. Which returns another iterator, of course. A group. Iterator scatter. Because again, M group iterators is a vector of standard pair of group iterator and group index, and we can just ignore the group index most of the time. So we just use the first one, and that then is, if you dereference that, we get a group. When not dereferencing it, we just increment it. However, then we could get the end iterator. So what happens? So we get the end iterator. Then we did increment the wrong one. It's of course not necessarily so that each iterator has the same length. So suppose that this one, the first iterator, iterates over 2 values only. And then we would get 104, 90, 68. Then we get this one, then we get this one. That 50 does not exist. So instead of doing the 50 then, you cannot increment this one. So then we wanted to increment the 68. So I would get that with a different 68. So this one's incremented to there. And then we can still not increment this one. So you want to increment that one. Yeah, I'm starting to feel that what we really want is to sort by the score of the next value. And I simply give a minus infinity score to the end iterator. So in this case we would sort by maybe I should sort by how fast it decrements. So it is 104 minus 98 is 15. And 90 minus 56 is 25. And 68 minus 68 is 0. And then I want to sort them in increasing order. So we begin then with the 0. We increment the 68 to the 68. Right, so this is probably all nonsense. So we get the second 68. Now this one has a value of let's say infinity, because it's the last one. And this one has a value of still 25. And this one has a value of 86 minus 55 is 13. So then this one is still the best, or the least, going down the least. That's kind of strange. Oh well, I guess it's okay. Then we get here 55. Now this one also becomes infinity. So then now the lowest value is 15 here. So then we get 89. And then we have infinity, infinity and 25. So the next one is obviously going to that one, and then finally to 40. And then we have 3 times infinity. This one also has a value of infinity. And therefore we stop. So that means that I need to determine the score of the next group. That really sucks. See if I can do that. Group iterator scatter. Static group is nothing, but this thing is pretty huge. No, it's just a consider. This is pretty huge. It's a whole multi-map. I mean, I would have to increment this iterator, but my iterator cannot go backwards. So I would have to make a copy of it. And that would include this multimap. Which would be ridiculous. I think I can better make a peak. Actually only need the score. I could add a new member function to group iterator scatter that returns the score of the next element, if it exists. Starts to get ridiculous, but well. Score, group iterator scatter. Let's not use the word element, that would be confusing. So that would be if the iterator is currently at the end in terms of, yeah, I could look at this one, I guess. It's kind of the safest thing. So if it is at the end already, then I'll return plus infinity. And otherwise, I can get the next group by doing this. And that might be the end as well. Confusing. We should never be at the end. Yeah, you cannot call score of next iteration when you are at the end, so better make that an assert. Let's just copy this. In method A and Yeah, and I meant in current A. So we are not at the end, therefore we can increment our iterator, and if then we are at the end, we return positive infinity, and otherwise we return the previous score minus the next score. It's not the score of the next iteration, it's a difference. Okay, so I need to have the score, of course, the current score. So again, that was an iterator into this multi-map, so that should be a pair, dereference to a pair that contains a score and a group. So we just need to get first. That is then the score. Right, so this is in increasing order now again. So the infinities are at the end. And that means that the first iterator, if that is has a score of infinity, then, well, actually the difference, if it is end, let's put it that way then. So this one is the one with the lowest score difference. But if we are completely at the end, then incrementing the iterator is going to be end anyway. So if gis is then the end operator, then we also reach the end of the partition iterator. So So then I have to set the partition iterator to the end, and that equals create the end iterator is simply having an empty partition vector. Okay, otherwise we did the right thing here. You always have to increment the first iterator, but now we have to resort our mgroups iterators because we changed it. I could just call sort again, but let's see. The problem here is it is sort. If I use the begin, it's slightly less efficient. I have the feeling, because now I have to continuously shuffle around the beginning of the vector, or yeah, no, I don't think it really makes a difference. I have to shift elements anyway. So we have a vector, let's say with the values 100, 90, 80, 70, and so on, ordered in decreasing order, right? Yeah, no, infinity was at the end. So these are differences. So we have something like 10, 20, 30, 40, ending with infinity. And that's how we sorted it here. And now I'm incrementing the iterator that belongs to the first one, so this difference can change. It can change to any value. For example, we could now have 100 here. No, let's not. Let's use 35. So then I think what we want to go to this, insert 35 here, so it's ordered again. Which means I have to move a block back and insert 35. Now vector is contiguous, so we can do this move in one go, I suppose. Well, not really. It depends a bit on what we store in it. Let's think here. This is this vector which contains pairs. Now the group index can simply be moved. Let's just wrap around an int value. It does have constructors, but I can ignore that, I think. I think it must be trivially copyable. Let's see. Or trivially movable, I don't know. I mean, if you really want to be conforming to the standard, it's kind of scary to simply move stuff in memory without telling the object that it moved. But okay, let's not call ourselves blah blah. So this is really just an int and you can move it. And this one, group iterator scatter. that contains a complete multimap. Okay, so you really want to move. The thing they must have support for moving. I think we can do that. Okay, let's stick to the standard and just move every element, and then hopefully the compiler is so smart to optimize it. I mean, that's how it should work. No, it's not gonna do that. I'll have to move elements one by one anyway, I think. There's hardly any speed up. Okay, let's go to let's go to find out what the documentation says. Standard vector. Does not have a clear support in standard vector itself, it seems. Nope. I think you have to call some external algorithm function like std copy or something like this. But I'm just gonna Google it. There's a standard rotate. Oh, like that. This is actually exactly what I need. So, assuming that however rotate is defined is the most optimal way to do it, since it is exactly what we need, might as well use it. I don't think we can get any more efficient. So let's have a quick look how standard rotate exactly works. I never heard of rotate before, you believe that? It's the first time I see it. Iter first, iterator n first. Performs a left rotation on a range of elements. Its Specifically, std rotate swaps the elements in the range first and last in such a way that the element n first becomes the first element of the new range, and n first minus 1 becomes the last element. Precondition of this function is that first till n first and n first till last are valid ranges. Okay, so we have this, and we want to move 0 up a bit, in this case to the very end, apparently. So then we do begin and end at the outer things, and then begin +1 here, and this is then the last element that must be shifted. No, one past the element that must be shifted. So our third iterator should be the first element that is either end or not, does not have a value that is less. Okay, so this ends with standard rotate. And then we get, well, let's call it end, where then end must be must point to the 40 here. So this would be that begin is now 35. Begin +1 is 20, and that becomes the next begin. And the end points to the 40, which is then not rotated. So now it rotates the 20 to there, 30 to there, and the first element is put there. That's exactly what we want. So now the only thing I have to do is get the end to point to 40, which is the first element that is larger than the 35, which means that I need to get my 35. So I need some kind of score. So I incremented this thing, and now I want to know what the new score is. Can't find tag pattern. Let's oops. I'll just add a new one again. Score. It simply returns the score of the current pointer, and then again you may not call it when it is already end. So we have here okay, that would return the score here. Our multi-map stores basically keys. It stores groups with key score, but if you dereference an iterator, you get a standard pair where the first one is a score and the second one is a group. So this, by doing the first on the iterator, then we get the key, which is a score. And that correct. Group iterator scatter has a score now. Yeah. And I should remove the name iterator here because it's just not an iterator at all anymore. We're gonna rename this to current score, I think. And now we're talking nonsense because these are not scores, they are score differences. Damn it, I need to get the new score difference. Yep. And then we have to run over all the elements of M group iterators until we find one where the score difference of that iterator is larger. Now, suppose that there is absolutely nothing that follows in the... Oh, it's going to end at the end. I don't know, but it should work, I guess. We'll just see. Let's delete this. So this is, you want to find something, probably standard find, and we want to find it in group iterators, and we just begin at the beginning. Do we begin at the beginning? No, not really. Let's begin at begin plus 1. Suppose we have an immediate hit, so end becomes equal to begin plus 1, so end is equal to this one. Then what exactly is it going to do? I hope nothing. Yeah, then it should do nothing. But I'm kind of scared to start at +2. Might not exist in stuff, I think. I think that standard rotate should work when these two are equal. So let's not care about it. Or does it? Well, let's test it anyway then. Let's like if let's just rotate if these are not equal. So I start looking at begin, and then obviously we're going to look until the end, possibly. And then we have to pass something. I guess this must be standard find if. Let's have a look at the definition there. Standard find if. Find if searches for an element for which predicate P returns true. Yeah, either find if or find if not. Depends on which predicate is easier to write. The type of the predicate, that would be nice. The expression PV must be convertible to Boolean for every argument V of type, possibly const VT, where VT is the value type of the input iterator. We pass the lambda, and the lambda takes as argument a value type of our M group iterators container, which is obviously this again. Okay, I'll call it V, like in the documentation. And then we return something that is true as soon as we reach the actual end, which means that the score difference of end is larger, right? So the score difference of end is larger than the new score difference. Is that true? Yeah. Equal would do as well. Let's use equal. How do we get the score difference of V? Isn't that just V dot first dot score difference? Right. Blah, blah, bum, 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 bum. It's probably not even going to compile, but it's about time to test it and then fix the compile errors. There is no match for operator less than. Well, we have to implement it then, I guess. I have implemented a plus, so I might as well implement a minus. Let's see this thing. It's not that big. Could pass it by value, I guess. But let's not do that. Going to work with the left hand side and right hand side. Const reference right hand side. And then let's say we have a result which we return. Let's set the result equal to the left hand side. And now we must implement the subtraction. Result dot number of positive infinities. Okay, now we have a operator minus. Class group is no member score difference. That's correct. I guess I did that because I thought I had to calculate the score. But really it is just the iterator that we have to use. Class partition has no member named clear. Oh, it's a partition. Wait. Nonsense. Calling clear on partition. This is better, right? Yeah, the class partition iterator scatter uses an end iterator that is default constructed, aka an empty vector, and end is also testing that. So to make this the end operator, I have to force this into an empty vector. So I was calling a clear on this one, but I meant that one, I guess. We can leave the partition whatever it was, original. So much. Why so much? Class group is no member named score difference. I think I scrolled up too far. Okay. Which make. That's strange. I have a make here suddenly. This has a filter. Yeah, it does have it here too. If not empty, use the filter. I have no idea why this outputs so much. Is the filter not working? I guess I'll have to live with it until I fix this bug. Maybe it's just one error. New score difference is not captured. Right. Well, let's just capture it by value or by reference. What do you think? By reference. No match operator larger or equal on score. Yeah, I have this one. I do not have greater or equal. Just add it. Feel like adding a spaceship operator. Yeah. Error conversion from some iterator to non-scalar type group iterators get requested. Because this is nonsense. That is not the type of what this is returning. Yeah, the return, the type of end is wrong. That should be the iterator type equal to the type of this thing. It's figured it out. Bang, that was the pages of errors. So now I think we have something that where I think this is implemented now to plus plus. What we do is we increment the we increment the iterator with the smallest score difference, and if that results in the end, and the smallest score difference was plus infinity, so we were at the end. Clear this and return the end iterator. Otherwise, you get the new score difference from the incremented iterator. Then we find the first element that has a score difference that is larger or equal, and then we rotate it so that it's again in order, in the correct order. I think that warrants a test, because it might fail. I have no idea if it is correct. So I just make a copy of it, sort it in the previous way, which hopefully works, and then they must be equal, aka this was already sorted. That might fail if the sorting key is equal for certain elements, because they then end up with a random order. We don't want that, so in order for this to work, I probably should change this one to make an absolute order. So instead of this, I'm going to return, let's say, if the score differences are unequal, and then I return the thing that we just returned. And otherwise the order doesn't really matter, but let's make it matter for this case, and the sorting on second in that case. So then we have an absolute ordering. It means second is group index, so that should definitely always be the same. Something went wrong. What is this? No match for unequal. Score also does not have an unequal, really. Yeah, maybe it's not really correct to use operator unequal here. What I really mean, of course, is that they are not less than, and also not reverse less than, because that we use less than as the real comparison here. This is the less than. No, I don't need it. Damn it. Okay, let's make it differently. So more like that. If they are not, this is, if left is not less than right and right is not less than left, then they are equal. this requires an operator equal for group iterator scatter and group iterator scatter. Oh. Yeah, I guess. And group iterators. So now I'm doing it still. Comparing it like that. But yeah, that is what I wanted to do, I guess. Do not have a vector compare. I have a vector compare, but that then requires an element compare. See that this doing it the same thing. Element compare left right true, else right left true, and return false. Otherwise we go to the next element. So I could just pass the less than as the element compare maybe. Then I have to call it twice. That would work though. Yeah, I'll just add an operator equal. My god, what a lot of work. Just to check if the array is sorted already correctly. Okay, I'm just not going to add an equal operator. Doesn't feel right. I have to do it with a less than. So I'm going to call here utils vector compare. And then we use something element compare that is testing for less than. The elements for of the this is a standard pair. Thank God I do have a pair compare, I think. Pair compare. Yep. And then we need a compare for the first one and the second one. And then the first one is a compare for the group iterator scatter, and the second one is a compare for the group index. The group index is an array index which has support for everything, for less than also. Group index. So we just use the group index less than group index, which is defined. And then the other one was group iterator scatter, which has no operator less than. But I think I made it. Didn't I make a compare above here? Yeah. Group iterator scatter. What is for the whole pair? Wait a minute. Group index. Yeah, I guess it is. This already compares the pair. It's a pretty damn difficult thing, right? It's not really testing exactly what I want. I just want it to be equal. As in, but yeah, on the other end. You have, I think it's just not worth it. Really, I'm not going to test it. Forget the whole assert. Oh, well, at least I could add this one, I guess. This compares a pair of group iterator scatter and group. This, I think that's it. Basically then my pair compare thing. Const problem. I don't see which function is missing the const. I mean the element compare. What is it? Element compare is very const. So the type is the element compare. And that's a group iterator compare. So const missing here. Horrible things are going wrong again. Duplicated AC. Removing the JNO worked. What is the EO doing here? That's a duplicated O. And a duplicated E. This does not make sense, I think. Oh well, time for the debugger. I think, ish, at least. In the end, it's going to need a lot of debug output, I think, but let's see. Yeah, this one looks good. I think I'd rather look at one that is immediately wrong. Thank you. Producers. I'm from the Netherlands. And my eyes are hurting. Why? Doesn't feel good. I should go to a doctor or something. Have to have my eyes tested. Okay. Yeah. How did I learn C++? Well, just reading on the internet, coding a lot. The assertion fails. In Valorant it runs for a long time and then the assertion fails. But okay, we have definitely problems before that. Invalid read of size 8 in score difference. Well, let's begin with trying if this also happens when I compile in debug mode. Something goes wrong in score difference. Well, I guess it's trying to sort. Let's run to the debugger. Hmm. Hello, Julien. What is this? Why is it crashing? Hmm. Nothing wrong with this one. Yep. Well, it looks completely normal, this one. So we call sBegin on that. And that uses it to construct an whatever this thing returns. Partition iterate or scatter. So that means that while we're here, original must look the same. It does. I guess I'm gonna put a breakpoint here and see if anything weird happens here. I don't think so, but group index. Starts obviously at 0. And that's we get the first group here. Element count is 3. And since that's larger than 2, we can place back standard make pair of G and GI. Yeah, okay. That's not right. Remember that said this previous stream that if we have a triplet, we should not generate the whole triplet. If I remove the complete triplet from a triplet, we end up with an empty group. So if this is the leading to our bug, I doubt it, but well, it could be, I don't know. Anyway, we shouldn't do that. So where does this thing come from? That is what we just placed back. Quite confused here. Yeah, must be just put back, but No idea. Let's look at the source code. So there's a problem in this line basically, 26. Iterators takes a group iterator scatter. Are we passing a group? So yeah, must be the constructor of the group iterator scatter. Huh? Shit. Okay, now we have 3 elements. Let's print it in hex. So I have 3 bits and I'm just generating 3 subgroups namely 1 1. So leaving out the 2. And 3, leaving out the 16 bit here. And 12, leaving out the 1. Looks better. Next. Guess that's the next group. Yep. The thing has lots of bits. Nine bits. Frame. Nine. Damn it. Keep forgetting the X. So yeah, the original is 4 bits, and then we get 3 elements. And if the original is 9 bits, that one, then we have 120 elements apparently. Well, that should be like 9 times 8 times 7 divided by 6, I guess, plus 8 times 7 divided by 2. 9 times 8 times 7 divided by 6 plus 9 times 8 divided by 2 is 120. Okay. So I guess that worked. So this is a triplet. It has a 3-bit set. And this is a triplet, and this is a triplet, and this is a pair. This is a triplet, and this is a triplet, and so on. They should be sorted by score. And the score is printed as well, so this score should be pretty damn low. Value of 0. It probably was negative. Oh, that looks negative. Let's print it without. Oh, the one now. Nah, whatever. It's zeros and then 1 and then 5, so it's indeed sorted. Gets larger and larger. Yep. Yeah, hi. I got distracted a bit. Ish. Theoretically, it's to decide how to divide the shader resources over the scripter sets. But yeah, it's definitely gotten a bit silly. Oh, I don't know. It looks normal. Okay, whatever. Frame. Until we get the next group, then. That is a bit strange. No elements. What? Oh, that's possible, I guess. Element count means we are at the end. Yeah, of course. Okay. And now if we try to sort this, we crash. What is this? Oh, we really only have two. One with 3 elements and one with 120 elements. Okay. Yeah, this is a single triplet, so that resulted in 3 pairs. And this is 9-bit set, so that resulted in 120 pairs and triplets. But this is only 2-bit set, aka it's a pair. This is also, so that didn't add anything. So in fact, it's correct. Then why on earth is this crashing? Maybe I have iterators that point to things that I'm moving here. I think I do. I'm afraid I do. Cannot sort it like that. God, why? Really? Yeah. Sorting M group iterators is a bit problematic because it contains a group iterator scatter object which contains a multimap and iterators into it. So as soon as I move this element here, then my iterator is no longer pointing to anything that makes sense. And therefore we have to reinitialize it. It's kind of the question, when does this thing here need to have a valid value? It needs to have a valid value when I call these things here, plus plus and dereference operator. But also in score difference is being called. Tired. I think I'm going to take a break. Oh man, it's a mess. I guess I should not use multimap, or better, I should not be swapping multi-maps back and forth in memory. I think I go for the latter because that sounds inefficient to begin with. Therefore, this thing here must not be influenced. This thing here must not be influenced by moving it. So I could make it a shared pointer or something like that. A unique pointer? Probably not. Do not allow copying. See what happens. And then my window disappeared. Ah, there it is. Use of deleted function. Yep, making copy here. It's totally correct. In an instantiation of const expression, rotate quite from here. Implicit deleted because the default definition will be ill-formed. I guess rotate needs a copy or move. And I deleted the copy constructor, which then also deletes the move constructor. So we have to add the move constructor back, because that's not a problem. You can have your move constructor if you want. fact check it. If you add a move constructor, like, well, if it's a custom move constructor, then it will automatically delete the copy constructor. But let's be clear and just explicitly delete it. Clear and or certain. Still a problem with rotate. Also assign. Also assign my pair. What does it want to assign here? Not really an assign, it's a move. It needs a move assignment. Ah! Now pair probably has a move assignment. Yeah, move constructor was not really what we needed. We need a move assignment. I can keep this as well, of course, but let's add a move assignment operator. I think we can even do that one by default. AKA let the compiler take care of it. Now I don't want to hear any bitching from rotate anymore, but and it doesn't. Oh, isn't that great? It's now whining about something else, namely check constructible. Required from uninitialized copy. Required from. Required from vector. Required from here. Vector needs something. Vector needs something. What was it? I forgot it. I think vector needs assignment. Does it really need it? Shit. My memory is failing me here. Yeah, it's not clear at all. It is constructible. Does it means that you can construct this from that or the other way around? Hmm. So I'm pretty sure that you can store objects that are only movable in vectors. But I cannot remember the details. Okay, let's again write inefficient code instead of putting time into this, because it's not the main project. So forget about that. Because that's memory. Yep, memory. Great, you're no longer crashing immediately. Now we just have an assertion that fails. Let's see if what it prints so far is if that makes sense. So this is what we begin with, and then we move B out of AE. That looks good. And we moved J and O out of this one, and the GK and the LP are left alone. Then the next one should only change one of them, and apparently this one. So we still have J and O, but now the E was moved out of it. And then we still have J and O, but now the A was moved out of it. And then we do that again. Actually, do not do that again. Now we stick at the last one, and now we finish this one. So that would be around 120 different things that are moved out of it. All that time keeping it at BE. That does not make any sense. Damn it. But it does do what I programmed it to do, I guess. And all that time the sorting was correct until this point. Why would it not be correct anymore here? I guess because we got here. No, because we still do this, so we did not get here. Let's print both, and then we'll probably understand it. So if this fails, I do not have support for printing multimaps, I guess. You cannot print a group iterator scatter. Strange. Normally I'm pretty insistent on being able to print absolutely everything. Yeah, I did not add it. Void print on standard stream reference as const. Okay, we have an original map. I don't think I want to print it every time. Probably should. Okay, let's just print everything. With new lines, also not really what I normally do. Oh, I think I already know what the problem is. We do not have a deep compare, of course. So I think then we're just comparing shared pointers. Nevertheless. And I still don't understand why it would go wrong, but it's not correct. Or is it not what I'm doing? Maybe not. No, not, because I'm not using operator equal. Only using operator less than. Okay, so for let's see if that works. To prints here stuff, meaning that I think it is going wrong here, or did it go wrong first? No, this test is, yeah, it goes wrong before that. Yeah, of course. Print unequal, okay. Group iterators equals first or original is this group. Let's see if that's correct. Yep. And then we get with the score and then the subgroups, the pair of triplets that we could get out of it. So 120 of those. And the current is pointing to the last one, apparently. And then the second one is, oh sorry, second is a group index or something. Then the next element is ABES, original, and 3 pairs. And current is pointing to the last one. So that is definitely related, I think, to the problem. And then test itself, so after sorting, still exists of this same thing. First M original, that JNO CFM, JNO CFM, probably the same, right? It ends on JMMN. Oh, wait a minute, JMMN. Oh, that's the same, even that is the same. Current points to the last one. It's the same. First original ABE, also the same, also points to the last one. Well, that's interesting. I remember this recognizes chill MP. That is indeed the correct solution. Part off. I'm not so sure about the rest though. Promising. But I don't really understand why it compares these two things differently. So let's write into a file. No difference. So why does it say that there is a difference when there is no difference? Really? Oh no, it doesn't say that. Oh wait a minute, it does. Unequal. So when we print unequal. Hack. Anyone wants to know what hacking is? This is in my definition hacking, what I'm doing now, what I'm going to do now. It is on GitHub, partitioning or something like that. Partitions, yeah. Initial commit, really? Huh? Okay. 2 branches. Default branch, branch. Yeah, well, there it is. Somehow this stupid GitHub thought that the word master is not allowed anymore. I mean, fuck you. So now we get confused because it creates main. I want still to use master as my branch, so you have to manually switch to it. Apparently. I didn't push the latest thing. If you want me to push that, then I can do that. Yeah, I wanted to print both values. Let's just print them. So if CIC1, then I'm gonna do this again. else we do the other one. I'm going to set some global flag. Yeah, this is the hack, right? Global flags. Set it to true. I'm gonna use that inside this compare to see where it goes wrong. So this should never return true. If things are equal, then things are never less. So we cannot return true. And here we are allowed to return true, but if we return true, that would cause the problem that we have. So let's return the demand is that the hack is not set, or it's not so that the second is less than the other second. Now we have a nice core dump. It goes wrong on second, which I'm not printing. That is kind of strange. I want to see it, so we can run this in the debugger. There's more difference. Just completely different. 19. Oh, it compares scores. You have to look at the score. The score is also different. 5 and 0. I don't even understand how he got here then. That goes wrong in line 18, right? Line 18, and then apparently the score difference of the left hand side is not less than the score difference of the right hand side. Same there, but second is different. Maybe it's just me. I'm guessing this is infinity. It's positive infinity, yeah. And this one is also positive infinity, of course. But those are different. Why? Sorry, I had to get yawn. Yeah, why, and why not before? Possible. Well, it's not impossible. This points back to the original group, and I guess that the scores are always different, except when you get at the end. At which point sorting doesn't care anymore, so it puts whatever first. However, it shouldn't, because this is what the sorting should be using. So it should sort it by this second value then, and we would still need to end up with something that is the same. YouTube user, what do you mean with how is this compiled? With the compiler? Okay, I'll assume that you're not dumb and really meant something serious. Yeah, I compile it by typing make. Whoops. But my make isn't actually a bash script, and in the end I run this, and that's how I compile it. Now this is just a filter which fakes a TTY, then starts CMake and filters the output, so we can ignore it. This works equally well. If I type make, then this is empty, so in the end we run this. Too much in the debugger. And this is just a directory. I mean, it doesn't really matter what it is, does it? But then of course you also need to know the configuration. So I type configure, which actually is also a bash script, which loads a compiler environment. And then runs this line here. So I'm not using an IDE, but I'm using a lot of bash scripts, which actually form my IDE then. I'm also using a directory dependent history and environment. So all these environment variables that I use everywhere, they automatically switch if I go to a different project. So for that I use CDEH. It's also a making of myself, which I very highly can recommend. If you program from the command line, at least on Linux, then it's unmissable, absolutely unmissable. So you go to my home page, then you have here something with directory, right? It's just old. CD8, yeah, directory dependent history and environment in bars. This page. You could just install it the way it is described here, downloading and setting up, and ignore this. You can just make up your own system for environments. I'm not using this anymore, it's also just an example. These are just examples of environment variables that you could be switching when you change the directory to a different project. But you can make it up yourself. So paste this link as well. It's really, if you use Linux, yeah, really you gotta use this. Seriously, I mean it. So it works as follows: you install it, and then you can type add history, which is a command. In a certain directory, and then from that moment on your command history will be separate in that directory, or any subdirectories. You will have a new history independent of the other histories, and you can add files, env.source, just add a file in env.source to any directory. And then if you are in that directory or in any higher directory, so in subdirectories of that, it will source it. So you can put it in whatever you want. And then, well, there are a few commands like, well, no, it's not true. I think so if I type PE, it prints all the environments, environment.source files that are sourced. So this print environment. But in fact, the which PE, I'm not even sure where the alias PE is defined. It might be part of the install. So that might be part of this env.bash rc file. I can only download it. Nope, it's not. So I must be declaring that in one of these. Maybe here. Let's see. Can finally back. It's probably function. Not in here. Not in here. I don't know. It's definitely not in partitions. I don't know what P is defined. Well, it could also be defined in my dot bars RC in the home directory. Yeah, there it is. P. Print a list of Android source files. Okay, what was it doing? I think the sorting just works. If the score is the same, then apparently it mixes up. Although it's highly confusing. It should never happen. Damn it. Why is it happening? Yeah. The problem is that... Oh, wait. I think I understand. Yeah. No. 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 Yeah, I don't understand. Why is this happening? Yeah. I'm using Linux. Yeah, I understand it. Finally. The reason is that my lambda here is only comparing the score differences and not when they are equal the second value. So larger or equal is the same as not less than. And what I really should be using is the same compare operator, so same as this, I guess. Oh, this is not good enough. And the assert is gone. Isn't that like magic? Okay, so that seems to be working-ish. Now the interesting thing is that, well, let's not print this anymore, because it kind of works, doesn't it? Crap. Partition 2 equals now if I do not run this through my scatter, then let's say the score is whatever this score is. Let me print it. Print the score up front. Let's print the score for online partition. On some reason I have a notice in front of it and this one doesn't. Yeah, still not using libcwd everywhere. Oh well. Okay, so the interesting thing is that before we had a local maximum, this one, with a value of 126, and I shake it and then we get way higher. Interesting. Now we're going to do the 10,000 things again. No, well, let's start at 10,000. Did I 10,000? I cannot remember what it was. What it's printing now is what I was printing in the loop. So these are the old local maxima. And it's going to do this like 10,000 times, I'm afraid. It's maybe a bit much. Especially because it got a lot slower. Let me change it to 1000. Hell, I don't want to print them anymore. Thousand. How long is it going to take? Could easily take 1 or 2 minutes, I think. Okay, I'm going to hold my breath and if it, oh, there it is. That's a major improvement, isn't it? 16 elements and only 1, 2, 3, 4 wrong local maxima that it gets stuck in. It's pretty good. That is really good. And I mean, especially the half of them, more than half of them, more than 500, find the correct solution now. Which means that if the thousands, the chance that I would not find it with 1000 random starting points is 1 in 2 to the power 1000. It's ridiculous, of course. Absolutely do not need to use 1000. So first let's make it 100. Then I'm actually going to speed it up a bit because that check is no longer necessary. It's something with heck. Let's get rid of this heck. Also no longer need this compare then. I might as well and in fact I can change this back, because this is also slower than what I had. So this was, if I remember correctly, something less than was it not greater or equal? Yeah, we're looking for the score difference of V. Being large or equal new score difference. Yeah. It's not a good sign if they don't make a mistake. Okay, it's more like a typo. Partitions. So this output should definitely still be what we had before, and I'm pretty confident that it is, right? Just 5 in total. This is the maximum, yeah. So what I just removed was correct, and then we can compile with optimization. That makes it a lot faster. I want to run through Valgrind just to make sure that there's no surprises there. No uninitialized memory accesses. Very good. And then I'm going to edit element.h, and we're going to 30. Uh-oh, how long is this going to take? Might actually explode. I have no idea how long it takes. Oh, wow. Okay, pretty damn fast. And again, 25 of the 100 is a quarter with 30 elements. Wow, so good. That's really damn good, man. So the chance that we would miss this, assuming that this is the correct maximum, of course, but I think it is, right? So assuming this is the correct maximum, then the chance that we would have missed it with 100 random starting points is 1 in 3/4 to the power 100. 0.75 to the power 100. That's not going to happen anytime soon. 3 times 10 to the power is minus 13. I should have done 1 over, I think. So 1 in 311 million. No. 3 times 10 to the power 12. So 1 in, yeah, 3 times 10 to the power 12, whatever that is. That's pretty good, especially since I only need like 99.9% certainty. Not 6 sigma. Well, do I dare to go even larger? That is the question. You know, I'm actually curious if it works if I change this to 32. You just use all the bits. I wouldn't be surprised if it broke. Cordoned. Bad alloc. Oh, damn. Allocation. So it uses too much memory. Wow. Oh, you're lucky that 30 was even possible down there. E1? Also not. Create a new. So it's trying to allocate more memory than I have, apparently. That's kilobytes, megabytes, gigabytes, 77 gigabyte. Yeah, I don't have that. Why is it trying to allocate 77 gigabytes? For G-scores. Oh, right, yeah. So I'm making a vector for to store the scores of all the pairs. And I'm doing that apparently very inefficient. Very inefficient. You gotta be kidding me, right? Yeah. That's ridiculous. Okay, can we fix this quickly? So this is my unsigned int, 32 bits, and then I set the highest 2 bits, and I want to use that as an index. Well, of course we can do that with less memory. Accessing it might get slower, however. Hello, White Duck. I'm just making fun of you. White Duke. Max score index is a bit large. No, I want to know where we access this G-scores thing. Quit, yes. Wrap. Hello, Cafardo Nihilist. You're sitting in an empty room with just a PC. No, you're using a phone, of course. Or I'm not understanding the nihilist thing. I think I should take a break and then make dinner and stuff. Return. It's usually quite a few places. So element pair has a bit mask with just 2 bits set. And when I ask for the score, I use that as a the index. Very fast. But what is get pair doing? No, just running m element pair. No, silly. So yeah, well, normally I'm not doing that. In member functions, let's just access it directly. Compiles to the same thing, but too long is just getting the mask of this bit mask. It's a bit mask. So apparently what I want is to convert a bit mask with 2 bits being set to some kind of unique index, and then the total number of indexes are obviously equal to I guess the number of bits times the number of bits minus 1, all divided by 2. Which is a pretty slow operation. So if we do that, then maybe I should cache the scores and stuff like that. Yeah, I think that's my stomach just made a noise. Something for another day or later this evening. I'm going to make my dinner and then I'll be back later. So have a good evening and or night and or morning and or a few hours of or a good dinner if you're also in Europe.